Use the diagram information and proof to answer the question. Given that segment AB is congruent to segment AC, point D is the midpoint of segment BC, prove that line AD is a perpendicular bisector of segment BC. Okay, so I'm going to scan to see if we have any proofs, examples. So this is prove the perpendicular bisector theorem. We are not really given a similar proof on that. So we're going to just use this and step through exactly what it could be. So it says, what change, if any, should be made to the reason for statement 9? So I'm looking for this reason right here, perpendicular bisector theorem, and that's already kind of triggering something because we're trying to prove that it's a perpendicular bisector. So maybe there's a slight difference in this. So we'll go through. Given that, okay, so segment AB is congruent to segment AC, that's given. Then that means that the distance of AB is the distance of AC. So we have same side lengths right there. It says A is equidistance from B and C. Definition of equidistance. Well, yeah, they're equal distance because it's the same length. So then it says D is the midpoint of segment BC. That is given up above. So then it says that D bisects the segment BC. Definition of midpoint. So see how they established the midpoint and then they use it to state something else. So then they're going to say that we have a distance right here that's congruent to the distance of CD. Definition of bisect. See again, there's that statement link and their reason to the next statement. So that means that this distance, BD, is equal to the distance of CD. So definition of congruent segments. That means D is equidistance from B and C. Definition of equidistance. Yeah, it's equal distance because point B is the same distance away as point C is because these lengths are the same. So then it says A is on the perpendicular bisector of segment BC and D is on the perpendicular okay, time out. D is on the perpendicular bisector of segment BC. Perpendicular bisector theorem. Let's just pull that up. And so I'm scanning for a red. Here's one red box. I'm just going to read it to see for kicks and giggles if that's what we need. I know it says the converse right now. However, it might be helpful. So, if a point is equidistant from the endpoints of a segment, so here's our two endpoints, B and C, and we did state that it was equidistant right here, then the point is on the perpendicular bisector. So this is actually the converse of the perpendicular bisector theorem because they stated that it was the endpoints were equidistant from our point D, and again, so that proves this one, the converse of it, and point A is established right here as equidistant from our two endpoints B and C as well. So that is the converse of our perpendicular bisector theorem, and so it should be changed to the converse of the perpendicular bisector theorem.